Now let's discuss some of the major types of contact interfaces that you would be seeing in your analysis or in your problems as you are trying to model anything that comes in contact during the finite element analysis. I will put these types of contact interfaces into 4 different categories, and the first category, let's call it a weld contact. It can also be sometimes called as a hard contact condition. You can have a second one, which is a rough contact condition, which is sort of hard but with some kind of additional flexibility, as I will explain. You can have a third one called the stick contact, as well as the slip contact. This is something we have already seen before in terms of the frictional contact. Now, the weld contact is conceptually the same as using a rigid link or a tie constraint. That means we would not like to have any relative motion to occur in this kind of a contact. That means if there is a contact that happens between two different bodies, then they are in contact and will not be removed anymore. Of course, it allows some slight elastic deformations, but it does not allow any separation. Yeah. So let's say here we can say it's a contact without separation. Ballistic contacts could be considered as one of these kinds of cases. The second one is a rough contact. The rough contact is almost the same as a weld. However, after forming a contact which does not have any relative motion, the contact can separate. So this is the only difference. The third one is a stick contact, and in the stick contact, the relative motion is possible. So I'm going to write here that relative motion is allowed. And of course, this happens only within the elastic deformation range. That is the only allowable deformation. In this case, in the stick contact, you are only considering normal contact forces between two bodies, and therefore the tangent stiffness is taken to be symmetric. The slip contact, however, is the second one. We've already seen these examples. The slip contact is the one where relative motion is allowed, but the tangent stiffness does not remain symmetric anymore, because the relative motion that is allowed has to function as per the Coulomb friction model. This is a hard requirement, and because of this we have seen how it changes the description of the tangent stiffness matrix before, and it becomes unsymmetric. So these are the various kinds of contact interfaces. Now, of course, in a contact formulation, whether it is a weld type of a contact, a rough contact, stick, or a slip condition, there has to be a method which has to be followed to formulate this contact. The contact formulation follows a two-stage procedure. Contact formulation is therefore composed in the first stage of contact search. It's of course quite self-explanatory, and in the second step it creates contact forces. This is the two-step process for any contact formulation. So as the name suggests, the first step is a contact search. The contact search is going to search for nodes or segments that are in the vicinity of another object. So if you have, let's say, let us consider a simple example like this is a body, and you have a sort of a hemispherical surface which is coming towards this other body with the relative motion downwards. Then depending on the mesh of the body, if the body is meshed in such a way that you have nodes in these locations, here, 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 and so on, and on the second body you have nodes which are denoted by these crosses. and so on. Then the algorithm has to search for candidates of these nodes that are going to come in contact. So depending on the force that is applied over here to go downwards, or a velocity in case of an impact problem, it is possible that these nodes are going to be selected as candidates which are going to come in contact. However, because there might be certain cases where the nodes are not close to another adjacent node of the other body. So if this is going to go down exactly in the same way, which is vertically, you would see that this node over here will not have an adjacent node close to it. Therefore, this node will most likely violate the contact conditions. So what we need to do is, but these particular nodes that are going to be away from neighboring nodes, we need to apply a contact force in the opposite direction to avoid the violation to occur. So there will be a reaction which will cause the contact force to appear. Any nodes that are going to actually penetrate in this direction. So for each of these nodes that are going to be in contact with this body, you would have a opposing contact force which would appear. And the same thing would happen to the other body depending on where the other node is going to make contact. A contact force on the other body will also appear depending upon the properties of the body. And this is how the contact force is going to be developed. So first it searches for the candidate nodes or along the surface, and then creates contact forces for all the nodes that are going to come in contact with the opposing body. Now once these contact forces are created, then there have to be some limitations by which we can search for these nodes. So the definition of the searching algorithm will include a contact tolerance, which is going to be the minimum distance where you're going to search for contact, and the load increment is going to make a very big influence on the contact detection. Right? So if I give a contact tolerance which is about 10%, which is about 1%, that means the node must come very close to the other object in order to be first identified as a candidate node. So if the contact tolerance is very low, and I have some contact increments which have been defined. So if I say this is the original position, and I have increment 1 and increment 2 and increment 3 and so on, then depending on the size of the increment, I could easily miss the contact conditions. So if I skipped from, say for example, this increment over here directly to this one, then I would never come in the 1% range to be able to identify it as a contact possibility. So I do not want to miss the contact detection. Therefore, the size of the load increment is extremely important. So in order to have a good contact search, first of all, we must have a decent contact tolerance. Of course, if you make it really large, then it looks for nodes in very far away regions as well, so that makes the problem slower. And the second one is to make the size of the load increment suitable enough, small enough, so that you don't miss the contact detection. And once this contact has been detected, it is going to create the contact forces, as we have discussed before, that is going to create some opposing or reaction forces from one body to the other. Now, the rest of the things about penetration, about how penalty is applied and how the Lagrange multipliers are applied in order to create this contact have already been covered before in a simple example. And for a multidimensional system also, the same method will be applied, although it will be expanded.